Hi everyone, so I wanted to show you one more circuit, which is combination of both series and parallel connections. But before that, I wanted to mention how you basically compare these two connections and what is the difference. So as we calculated in the previous video, you see the current on the main branch for a series connection of the same two resistor is 0.25. Whereas if you put 2 and 6 ohms in parallel, what you get is 1.33. So, and our equivalent value in the parallel case is 1.5, whereas in the series case is 8. So you see that our equivalent is more in the series connection than in the parallel connection, right? 8 versus 1.8. 1.5. Therefore, the current is bigger because the resistance is smaller. The current naturally is going to be higher in the parallel connection because of the Ohm's law, right? Ohm's law is here, as you can see, I times R is equal to voltage. Voltage is 2 volt in both cases. It's basically, generally speaking, it never changes. It's whatever you have for the voltage source supplying. So basically, if you increase resistance, it's going to naturally decrease the currents. That's what you see in the series connection. So that's why we have all these complex circuits in electrical devices, electronic devices. And of course, this is like really the basic circuits. We have all these phones and computers and stuff as millions of different parts and different combinations of those different parts. So this is really, really the basic circuit theory. It's like A, B, C, probably not even B, C, just the A of the circuit theory. But in any case, our equivalent for the series connected 2 and 6 ohm is 8 ohm. Therefore, the current is lower than when you connect these 2 and 6 ohm in parallel. See, the resistance is smaller. Therefore, the current is higher in the parallel connection when you compare these two combinations. So that's why, I mean, depends on what you need in a given part of a circuit. You either connect your, resistors in parallel. If you need higher current, you connect them in series. If you need a lower current, so it all depends on what you expect from the circuit to do. So here, what I want to do is an example of the different connections combined together, such as you can have like series parts and then parallel parts. So let's take two parallels in a given circuit connected to a third one in series, right? So let me just draw this. This is the voltage source. So what you see here is one more step other than just having seriously connected or parallel connected, connected in parallel resistors. So you have, let's say this is R1, R2, and R3. So what you see here is that R2 and R3 are in parallel, as you can see, and R1 is in series with whatever you have in this part. Like what you would do here is basically find the R equivalent of these two parallel connected R2 and R3 and make that, find that R equivalent, let's call it R equivalent parallel part. And this one single equivalent resistance to R2 and R3 is going to be in series with the R1, okay? So let's give some values for these guys. Let's say this is 2 ohm, this is again 2 ohm, and this is 6 ohm. So what we know for this one, you're going to have this parallel part is going to be added as 1 divided by 1 over 2 plus 1 over 6, right? The parallel ones are added like that. So the R equivalent is going to be, once again, 6 over 4, so it's going to be 1.5 ohm for R equivalent parallel part of the circuit. So if you redraw, that's my strategy in these kind of questions. If you have multiple resistors, more than 2 resistors connected in several different ways, what I do is that take the smallest parallel part, find the equivalent resistance for that part, which I found it to be 1.5 in this case, and then redraw the circuit. So what I have here is R1, I didn't touch it yet. And what I have here is I'm going to write R equivalent here, because that's what I calculated, that's the parallel part. So I'm just redrawing the same circuit with knowing or getting rid of that that kind of smaller part. So this part is this part. Okay, so I'm gonna write this was 2 ohm. I'm gonna write this as, what was it, 1.5 ohm, right? So now you see that 1 and R equivalent of this parallel part is in series, right? So if I want to find the R equivalent of the whole circuit, so for this whole circuit, what is the R equivalent of this whole circuit? Not just the parallel part, but the whole circuit. Then I need to do this 2 resistance as they are because they're in series. So it's going to be, what is that? Because they're in series, as you can see, the current that flows over R1 is going to be flowing over R equivalent parallel. So normally what happens in the circuit itself is that the I in the main branch, this is voltage source, right? So this is the main branch current, flows over R1, flows and comes to this junction. So it basically goes over, splits into 2, goes over R2 and R3, comes back and merges back at this junction, adds up back to I, whatever the value of the main branch current is. So the same current goes back to the voltage source. So what is the whole total or equivalent of the whole circuit is going to be 2 plus 1.5. Therefore, it is 3.5 ohm. So this is the R equivalent of the whole circuit. So you can even further redraw it with one singular resistor that is the R equivalent of the whole circuit. So it's V, and this is R equivalent of the whole circuit. To find I, what you need is basically this total resistance value, which is the R equivalent of the whole circuit. So if the question was asking what is the current on the main branch of this circuit that you were given, and if the voltage is, let's say, I don't know, let's say it is 7 volt, just for the mathematical convenience, I picked 7, because I know that I is equal to V over R, right? So if the voltage is 7, the R equivalent I found to be 3.5, so it's going to be 2 ampere. In terms of units, most probably we'll get questions with milliamperes. Milli is 10 to the minus 3. Don't forget about that, because in real life, the currents that we can use in our regular day life gadgets are in milliamperes, not amperes. Amperes are really high current, and it would be really dangerous to have around. So I hope this is helping you in understanding how you treat these kind of questions. Like whenever you see a parallel connection in part of a circuit that is bigger than just those 2 parallel connected resistors, get rid of that parallel part by finding their R equivalent value and then replacing it and redrawing the circuit in a simpler manner. See, this is much simpler than what this one looks like. So, and then get rid of the rest, whichever resistance or series to that, value that you find. Add them and get rid of that part also, and just write them down as a simpler circuit like this. So what you do is basically reducing your picture into simpler form and even simpler form to a point where you have only one single resistor left, which is the R equivalent of the whole circuit, not just part of it. So this is how you approach to these questions. I have the current on the main branch to be 2 ampere. So what you can do further than this is that what is the voltage drop on R1, for example? That could be asked, like what is V1? Voltage drop on R1. Like if you put a voltmeter, if you attach, connect voltmeter to this resistance, which is R1, what voltage would you read? Because you find that I, the main branch current, is equal to 2 amperes now, right? We know that one. So we can go back and apply Ohm's law for this part of the circuit. So for this part of the circuit, again, V is equal to IR. And again, I'm telling you that Ohm's law can be applied on the single part of like one unit of the circuit, like R1 itself, or for the whole circuit or part of the circuit. The Ohm's law holds for each and every resistor that you can think of. So you can apply to R1 separately. So in that case, you're going to find what is the V1 on that R1. I was 2 ampere, R1 is 2 ohm, therefore voltage on R1 is going to be 4 volt. And so, which tells you that because the total voltage is 7. So if you look at this picture again here, you have 2 resistors that are in series. And what did we say about series connection? They share voltage, right? V1, and if I call this V2, V1 plus V2 is going to be whatever you apply, which was 7 volt, right? So if we found that V1 is 4 volt, V2 is going to be 3 volt, right? If this is 4 volt, as we found it, it is, V2 is going to be 3 volt because that's whatever the leftover of the applied voltage. So if 4 volt is on R1, R1 is basically spending 4 volts, and what is the remaining voltage is going to be on the other part, which is this R equivalent parallel. So therefore, if a question is asking you what is the voltage on R1, this is how we approach. You need to find the main branch current first by finding total R equivalent of the whole circuit, right? That's what you need to find the current on the main branch. And then by using, so again, step 1 is to find the total resistance value. R equivalent of the whole circuit is what you need to find first, okay? And you do that basically by adding parallel components first, getting rid of it, redrawing it simply, and then getting rid of the series parts, and then writing the total circuit as having one single resistor, which is the R equivalent of the whole circuit, and then using that R equivalent value for total current on the main branch. And by finding that, you're able to find what is the voltage drop on the R1, so which is 4 that we found. And by finding that, you actually are finding automatically what is the voltage drop on this parallel part of the circuit. And in this case, we found that to be 3 volt. And once again, what did we say about the parallel connection? Voltage is the same on both. And if we say 3 volt is on this parallel part of the circuit, it basically means that you would read, if you connect a voltmeter on R3, what you would read is 3 volt here. And if you read voltmeter, if you connect the voltmeter and read the voltage on R2, you would again read 3 volt here. So whenever you have parallel connected resistors, you would read the same voltage. So once again, on R2 and R3, if you read the voltage value, you would read 3 volt because that's what we found out that this parallel part of the circuit carries. So 3 volt on R2, 3 volt on R3. So if you need to find, for example, what is, if this I, the main branch I, splits into these I, say are I2 and I3, I'm naming them according to their resistance values, okay? I2 is what is flowing over R2 and I3 is what is flowing over R3. So if you want to find I2, which is the current on R2, that is going to be V divided by R2, right? Because I'm trying to find a current on R2. And what is the voltage on R2? It's 3 volt. I just told you that it's 3 volt. It is 3 divided by, what is the value of R2? It's 2. Therefore, it's going to be 1.5 ampere. And what is the current on R3? If it has 3 volt, which we found out that it has 3 volt, so you would basically write for this resistor here, I3 is equal to V divided by R3, and voltage on this resistor, as we wrote, is 3 volt. So it is 3 divided by 6 ohm. So it's going to be 0.5 ampere. And therefore, you get 1.5 ampere flowing over R2, 0.5 ampere flowing over R3, which is 6 ohm. And if you remember, the total current was 2 ampere, right? So 2 ampere splits in a way that 1.5 of it is flowing over R2, 0.5 of it is flowing over R3. Why? Because 2 ohm is a much less resistance than 6 ohm. That's why more of the current is flowing over 2 ohm. I hope this helps for you to understand these circuit questions. Have a good day.